Hello everyone and welcome to Butterflies, Pinwheels, and Wallpaper Investigation 4. This video is going to cover problems 4.1, 4.2, and 4.3. Our learning target for these three problems is that I will use the concept of dilations to understand similarity and how to use it to solve problems. Our ACES questions are listed here 1 through 10 for 4.1, 4.2 has 11 through 15, 26 and 27, and 4.3 has 17 through 20. In problem 4.1, which begins on page 76, we are going to be focusing on dilations. Well, what's a dilation, you ask? Let's take a look. A dilation is a transformation that enlarges or reduces a figure by a scale factor about a center point so that the original figure and its image are similar. What it's saying here is our center point P is going to be coming through the center of both of our shapes. Now these are similar because they wind up having the same angles and then similar scale factor on their sides. Okay, CB is of the same scale factor with ZY as AC is to XZ. We'll go over that a little more here in a little bit. If the scale factor is greater than 1, the dilation is an enlargement. If the scale factor is less than 1, the dilation is a reduction. So as we come back here, we're looking at the same shape here. And as I note, dilation must have a center of dilation. Think perspective, a perspective drawing that if you're drawing a scale of something, that maybe you're drawing a mountainside, you're going to go from where you are sitting, and what you are looking at is also the position you're going to start your drawing from on your canvas. Now, when we are dilating, we talked about you multiply by a factor. When x is greater than 1, it's going to get bigger, and when it's less than 1, it's going to get smaller. A repeat here, dilations must create similar shapes. Well, what are similar shapes? Similar shapes must have the same corresponding angles, meaning angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. And then the side lengths are proportional. Say that this is the x here is 2 going from this triangle to this triangle. Well, if that's the case, then the side length of XZ is 2 times the side length of AC. Also, the side length of ZY will be 2 times the side length of CB, and so on and so forth for XY to AB as well. If we look at the straight line from P through B and Y, if you look, there's our point P. To scale, we touch the angle B and we also touch angle Y. Over here, we touch C and Z and A to X. So all three straight lines are able to touch the points for both of our triangles. As we look at 4.1, it says complete the dilation of PQRS with a scale factor of 3 with center 0, 0. What that means is we are going to dilate from point 0, 0. And to get a scale factor of 3, we are going to take and go from X, Y, okay, to 3X, comma, 3Y. All right. So right now, change colors here. Right now, point Q is at 2, 2. Okay, 2, 2. So if we're going to 3x, 3y, that means that point Q has to go to 6 and 6. And so that point would be here. Okay, point P is on 2, 4. If we're going to go 3x, 3y, that means we're going to go 6, and then 4 times 3 is 12. So 6 all the way up to 12 here, and that would be our next point. And I'm going to let you continue on and do points R and S the same way. We go from XY to 3x and 3y. Same thing, if we're going to complete the dilation with center 0, 0 and a scale factor of 1/2, we are going to need to go from X, y, oops, it's good parentheses there, to 1/2 x and 1/2 y. All right. So if we have point 0, which is at -4, -4, 1/2 of that is going to be -2, -2. Okay, so we would put that there. Point P is at -2, 4, so we would be at -1, 2. And each of those is half of the prior one. So that's 4.1. Get used to changing by our scale factors of 3 and 1/2. Again, 3 was greater than 1, so this one is going to be larger, and 1/2 is less than 1, so this scale is going to be smaller than the original. So move on to page 79, and Butterflies, Pinwheels, and Wallpaper 4.2. It's asking us, are shapes similar, and how do we know? Well, is this shape with ABC similar to shape PQR, and how do we know this? Well, if we look, we're going to see that angle A is equal to angle P. We're also going to see that angle B is the same as angle R, and angle C is the same as angle Q. Now, to find out if they're similar, I'm going to jump ahead a slide for us here and see that if we know that line PQ is equal to 12 and line AC is equal to 4, we can start out our ratio of 12 to 4. And we want to know what the length of side X is. Well, BC is the same type of length as, or same side as RQ, or QR if you want to go that direction. And so if we know that QR is 5, okay, then we're trying to find X. Well, the way we do this is we go ahead and cross multiply. So we're gonna take 12 times x, okay, equals our 5 times 4, or 20. Okay, 12x equals 20 because we're cross multiplying. We divide both sides by 12, and we wind up with x equaling 1.66 repeating, or 1.67 units. So the length of x would be 1.67. And that's how we check similarities, and then we should be able to actually grab our ruler or whatever unit of measure we're using and be able to measure that and see that it is actually similar. Another way to check if things are similar, again, all of the angles need to be the same. They don't all need to be the same on that shape, but all the angles for this larger shape need to match the angles for this smaller shape. And if we grab our rulers here and measure on our page, we're going to see that length DE is 43 millimeters long. Also, if we measure length TU, it is also 43 millimeters long. So our angles are the same, and our side lengths are similar. In fact, they're the same on the one side. On the other side, EF is 22 millimeters, and we would measure and see that TS is 11 millimeters. And again, that leaves us with that transformation that we looked at before, only slightly different for our dilation. Is X is going to remain the same. Okay, we're going to say that x is the same, and that y now from 22 down to 11 is 1/2. So that would be our dilation rule for these two shapes. Okay. If we go to 4.3 on page 81, what we're working on here with 4.3 is being able to check similarity without transformations, meaning if we had two triangles sitting beside each other, or in this case inside of each other, that can we check and see that they are similar, and what are ways to do that? Well, they both share angle B right here, so, or angle B, angle Y, it's the same one. So it is has to be the same by default there. If we look at angles C and Z, they look very, very similar, and also A and X look very similar. Well, we have these two lines here. Line AC and line XZ should be parallel lines if these are similar triangles. So if we draw in our parallel lines and we have what we would consider our two transversals, well, that allows us to prove that the angles are the same because we have, based on our rules that we learned in investigation 3, we know that angle X is going to be the same as angle A, and angle C is going to be the same as angle Z. So we can look at that easily because we have parallel lines and see that this is a similar triangle. So that's all we're doing here in 4.1 through 4.3. We did dilations and similarities and being able to recognize those, and that's it. Ways to identify. Again, you might want to go back and watch again, slow it down, take some notes about ways you can look at shapes and identify those similarities. Now that you know everything that we are covering and talking about for 4.1 through 4.3. So here are your ACES assignments again, 1 through 10 for 4.1. 4.2 is 11 through 15, 26 and 27, and 4.3 is 17 through 20. So good luck on those. I look forward to your questions and comments in class.